Well, today is a huge day. Why is it a huge day? This is kind of the last real day of new notes. So we still have some, practice days coming up. I'm going to give you some notes on some review days, but this is the last new topic I'm ever going to teach you. This is crazy. This is monumental. So get a real clean sheet of paper, label it day 123. 122 was that practice day with inverse trig functions. Kind of combine days 121 and 122 sometimes. But this last topic is called integration by parts. Okay, before we get into that, let's do some warm-up questions of some past day material that will still be on your next test. Number one, if f of x equals 1 minus 2x over x plus 2, find the value of the derivative, so d over dx, of f inverse of x at x equals -3. Okay, so this is that tricky derivative of an inverse thing. And you could, in this case, find the inverse, switch x and y, take the derivative, plug in the number. But it's a little more work than the other way, and there are some times when that's not possible. So it's been a while since we've done one of these, but remember, if I'm looking for the derivative of f inverse of -3, that's essentially what this is saying, find the derivative at x equals -3. And the only reason they write it like that is because how ugly does this look? F inverse prime of -3, ugh, nope. That's why I usually use g. When we did this before, we said let g equal f inverse. Okay, anyways, derivative of f inverse of -3 should equal 1 over f prime of something. Remember, our first step was to figure out what that number in there is. And this is where you want to think, okay, if -3 is the x value of the inverse, here's xy, the inverse would be yx. So if -3 is the x value of the inverse, that means it's the y value of the original function. So my first step is to figure out what x value goes with that, because that's what goes in here. So set -3 equal to 1 minus 2x over x plus 2. Cross multiply, so -3x minus 6 equals 1 minus 2x. And if I add the 3x over, that would just be x. To subtract the 1 over, we get x equals -5. Just kidding. Math is hard. You'd get x equals -7. Okay, so that's the x value that goes with -3. So we need to put -7 over here. So to find my answer, I'm basically going to have to figure out what f prime of -7 is. So I never had to find the inverse of this, but I do have to find the derivative of it. So f prime of x is going to be the bottom, x plus 2, times the derivative of the top, which would be -2x, minus the top, 1 minus 2x, times the derivative of the bottom, 1, all over the bottom squared. Okay, and let's cheat a little bit, not show all the work. This is going to be -2x minus 4. Distribute the negative, you're going to have a -1 plus 2x. So those will cancel. This is going to end up being -5 over x plus 2 squared. Remember, we need to find f prime of negative 7. So negative 5 over negative 7 plus 2 squared is negative 5 over negative 5 squared, which is negative 5 over 25, or negative 1/5. Okay, so that is what goes here. This is 1 over negative 1/5, which makes your final answer. Multiply top and bottom by 5, negative 5. Okay, so the derivative of inverse, hopefully you're starting to get more comfortable with those. The value that you're looking for on the inverse, you got to find the x value from the original equation that goes with it. Take the derivative of the original equation, plug in that x value, and it's 1 over that x value for your answer. Okay, number 2. Let's do a limit. I want to know the limit as x goes to 0 of sine of x all over x minus sine of x. Where do you think we start with that? Plug in 0. What's sine of 0? 0 over 0 minus sine of 0. 0 minus 0 is 0. So I get 0 over 0, which used to be bad, but now it's good, because what's that let us use? L'Hopital. So this is going to equal derivative of the top, what's derivative of sine? Cosine, over the derivative of the bottom, 1 minus cosine of x. Evaluated at x equals 0. Remember the notation, put that in. So this is going to be cosine of 0 over 1 minus cosine of 0. What's cosine of 0? 0's cosine cycle starts at 1, so it's 1 over 1 minus 1, which is 1 over 0, which doesn't necessarily mean undefined anymore. Remember, 1 over 0 is not indeterminate. That means you're either going to positive or negative infinity. And you have to decide which one. So is the bottom ever going to be negative? The top's always going to be positive no matter what. No, it's not necessarily true. But around 0, the top is positive. Cosine of 0 is 1. So anything close to 0, this is 1. So again, anything close to 0, it's just a little bit under 1. 1 minus under 1 would be positive. Positive over positive, it's going to end up being positive infinity. You kind of have to analyze it a little bit to figure out if it's positive or negative that way. Since around the limit, around 0, cosine's still positive, the answers are going to come out being positive here. Okay, one more practice question, and then we'll get to this new topic. Let's do the integral from 1 to radical e of 1 over x times radical 1 minus ln of x squared. This is a little bit different. It is u sub. Kind of looks like that inverse stuff we've been doing, because I have a fraction and I have a radical with a subtraction and something squared. But it's not exactly the same as those ones I've been doing. I don't need to let u squared equal something anytime soon here. I need to just let u equal. What should u be here? ln of x. Because if I plug u in here, then I'll have that u squared already that I need. And the other thing that this gives me, what's the derivative of ln of x? 1 over x. Which is great, because that's what I have here. Oh, I just noticed I don't have a dx up here. It's terrible. Make sure you have that. So my leftover piece is 1 over x dx, which means du is going to equal 1 over x dx. Perfect. So this ends up working out pretty nice. Now I do need new bounds. So if I plug in radical e, what's ln of radical e? Remember, that's the same as ln of e to the 1/2, and ln and e cancel, so that's just 1/2. What's ln of 1? Log of anything of 1 is 0, so that's 0. So my new bounds are going to be 0 to 1/2. Plug in your u first. You're going to have 1 over radical 1 minus, instead of ln of x squared, it's going to be u squared. And du is 1 over x dx, so I just need a du here. Okay, now what's this turn into? The radical, positive radical, with a minus, is sine inverse. So this is sine inverse of u, evaluated from 0 to 1/2. Which means I just need to figure out what sine inverse of 1/2 is minus sine inverse of 0. Well, if you draw this out, sine inverse, you get rid of the left. Positive means I'm in the first quadrant. Sine is opposite over hypotenuse, so what's the missing side? Radical 3 gives me a 30-degree reference angle, so sine inverse of 1/2 is pi over 6. Sine inverse of 0, we still get rid of the left. 0 is what type of an angle? Quadrantal. You got to think, where does sine is always the y value? Where's y equal to 0? And that's over here, because this is the point 1, 0. So what angle is that? This is angle 0 here. So pi over 6 minus 0, your answer is pi over 6. Okay, good? Good. All right, let's start this last topic. I'm going to start a new page. Integration by parts. Integration by parts is basically used to undo product rule. So it's used to simplify. Integrals of the form integral of f of x times g of x dx, or equivalently I could write it as the integral of u times v du. You'll see why I'm writing it that way in a second. Okay, so when you have two things that are multiplied and they're not both constants, or neither one is a constant, you can use integration by parts sometimes. So let's see where this comes from. First off, let's say I wanted to take the derivative of u times v. What would that look like? Well, it's just product rule. So it'd be the first u times the derivative of the second, dv, plus the second, v, times the derivative of the first, du. I'm going to move some stuff around. Let's say I take this term and subtract it over with this one. I'm also going to kind of flip the side things around. So I'm going to write u dv alone on one side equals derivative of u times v minus v du. Okay, so this is just product rule written a weird way. I rearranged some terms. And now let's say I took the integral of everything. So if I take the integral of every piece here, I could say take the integral of the whole right side. That just means I could split it up like that. So what this tells me is that the integral of u dv is equal to, what happens when I take the integral of a derivative? Those just cancel out. So it's u times v minus the integral of v du. And that is called integration by parts. Okay, so this is a formula. You can see it came from the product rule, kind of undoing the product rule by taking the integral of it. And you have to choose what u is, and then the other piece of it's going to be dv. So what I mean by that, you'll see in a second. But to help choose the u, I'm going to have you use something that I didn't learn until college. One of my friends in college showed me this. The teacher didn't even know it. So I'm not sure if a lot of people teach this, but it always works. Use Lipit. Lipit is kind of a acronym to tell you what you should choose for you. You go in order. If there's a log function in the equation, make that u. If there's an inverse trig function in the equation, make that u. If there's neither of those, but there's a polynomial, make that u. If none of those first three are there, e stands for if there's an exponential, e to something. And if there's nothing else in there, if none of those types of equations are in there, t stands for a trig equation. So you usually don't want to make things a sine or a cosine or something like that. That's what u is. Anything left in the integral will be dv. And I get that this probably doesn't make a lot of sense right now, but when you see it done out, hopefully it will. Okay, so I'll walk you through the steps on the first one. Let's do the integral of x times cosine of x dx. All right, now u sub's not going to work. If I let u equal x, I'm definitely not going to get a cosine of x. If I let u equal cosine of x, the derivative is going to be sine. I'm not going to have any sines. So u sub doesn't work. But I do have two different pieces that are not constants, x and cosine of x, that are multiplied. So parts is an option. So here's the steps. Step 1 is identify u and dv. We got to figure out what part of this integral needs to be u and what part of it should be dv. So I usually write it like this. Here's u, and here's where Lipit comes in. Is there any log function in here? Nope. Is there any inverse trig? Well, there's trig, but not inverse trig. Is there a polynomial? Yes. X is a polynomial. So x, this piece here, is going to be u. Anything left in the integral is going to be dv. So I'm writing this kind of down a level and over. You're going to see why in a second. So the thing that's left in the integral is cosine of x dx. That's dv. Okay, second step, take derivative of u and an integral or antiderivative of dv. Okay, so this is why I wrote it kind of weird over here. Take the integral of u, so du, what's the derivative of x? Just be 1. 1 dx, technically. It's du over dx. I want to write it as 1 dx. You'll see why in a second. And the antiderivative of cosine of x will give me what v is. So if I've got cosine, the derivative of what gives me cosine? Sine. So this would be sine of x. You don't really need a plus c. I'll show you why. That comes later. Okay, so there's the second step. Third step. Plug into formula. And by formula, I mean the thing from the top of the page. Integral of u dv equals u times v minus the integral of v du. So the integral of u dv equals the integral of v, oops, sorry, what am I doing? Equals u times v minus the integral of v du. That's the parts formula. Okay, so the integral of u dv, the integral of x cosine of x dx, thing I want to find, should equal u times v, x times sine of x, minus the integral of v, which is sine of x, du, which is just 1 dx, so it's just dx. Okay, last step, evaluate remaining integral. That's this one. And now notice it's an easier integral to evaluate. My answer is going to be x sine of x minus, so the integral of sine, the derivative of what gives you sine? Negative cosine. So negative cosine of x, there's where you need a plus c because there's no bounds on this. So my answer is x sine of x plus cosine of x plus c. And as always, you could always take the derivative of that, and you should end up with x cosine of x. All right, so kind of tricky, but it's kind of a cool way to solve some of these unsolvable integrals. Okay, let's do another one. Now this next one seems like something that wouldn't maybe even be integration by parts, but it is. The integral of ln of x dx. Some of you might even be thinking we've done this before, but we actually haven't. We've done the derivative of ln, but we haven't done the integral of ln. So I want to figure out what u should be, and the leftover piece is going to be dv. So think Lipit. Is there, what's L stand for? Log. Is there a log here? Yup. ln of x, so that's what u is. So that means the leftover piece, which is just dx, is dv. Okay, so now find the derivative of u. What's the derivative of ln of x? Be 1 over x dx. Antiderivative of dx. Well, think of it as 1 dx. The derivative of what would give you 1? 1x. So that's just x. Okay, then we plug into our formula. This should equal uv minus the integral of v du. U is ln of x. V is x. Minus the integral of v, which is just x. Du is 1 over x dx. Well, that's kind of handy. This is just, I'm going to put the x out front, x ln of x minus, it's going to cancel, the integral of 1 dx. So your answer is x ln of x minus the integral of 1. Again, we just did that. The derivative of what gives you 1? It's x. And then what do you need on the end? Plus c. So I think we have done in a homework the derivative of that, and your answer's been ln of x. But this is how you can start from ln of x and take the antiderivative and get that. Okay, good. I'm going to flip to a new page. Number 3. Let's do a similar one, the integral of x squared ln of x dx. Again, when you look at this, you might think u sub, but whatever you make u, the derivative of that's not going to be the leftovers. But you do have 2 non-constants multiplied. So we got to figure out what u is. Then go back to Lipit. What do you think u is going to be this time? It's going to be ln of x again, because it's log. And again, it's the first thing I get to as I go from left to right. Since there's a log in the equation, that's why I know to make that u. what would dv be? Well, if this piece is u, the leftovers are x squared dx. So now I got to find the derivative of u. The derivative of ln of x is 1 over x dx. The antiderivative of x squared for v would be what? Think of taking the integral, x cubed over 3. Okay, so now I know that this should equal the parts equation, uv minus the integral of v du. U is ln of x. V is x cubed over 3 minus the integral of v x cubed over 3 du, 1 over x dx. So this is going to be x cubed over 3 ln of x minus, we cancel that, this becomes a squared. So now it's the integral of x squared over 3 dx. And when you evaluate that integral, what can you pull out front? 3 is a constant on the denominator, so minus 1/3 times, then you would just have x squared dx. What's x squared going to turn into? X cubed over 3. And then don't forget, plus c. So it's x cubed over 3 ln of x minus, that's going to be x cubed over 9 plus c. If I'm going too fast, maybe go back and rewatch parts of it, and hopefully that will help. All right, got 2 more. Number 4. How about the integral of x squared e to the x dx? This one is soup fun. What do you think you want u to be? There's no logs. There's no inverse trig. There is a polynomial. E is the exponential. So polynomial is what gets hit first. So u has to be the polynomial, which is what? X squared. Which means what's dv? The derivative, the leftover piece, is e to the x dx. Take the derivative of u, it's the derivative of x squared, 2x dx. What's v going to be? Well, it's easy. The antiderivative of e to the x is e to the x. So here's your formula, uv minus the integral of v du. U is x squared, v is e to the x, minus the integral of v e to the x times du, 2x dx. Let's clean that up a little bit. It's going to be x squared e to the x minus, now I can pull this 2 out front, 2 times the integral of x e to the x dx. How do I take that integral? Yup, if you're thinking what I hope you're thinking, we have 2 things multiplied and they're not constants and u sub won't work, so yup, this is parts again. How amazing is that? Put a big smile for that. So we get to do it all over again. What do you think u would be? Same as last time. X is x to the first, that's a polynomial. That comes before exponentials. So u is x, which means dv would have to be the leftovers, e to the x dx. What's the derivative of x? It's just 1. So 1 dx, or just dx. What's the antiderivative of e to the x? E to the x. So, color code here, we have that x squared e to the x piece minus 2 times the whole parts formula again. So uv x times e to the x minus the integral of v e to the x du, which is just dx now. Okay, getting close. This is x squared e to the x minus 2 times x e to the x minus, this is an easy integral, I don't need parts anymore. What's the integral of e to the x? E to the x plus c. Then just distribute that 2 through. So it's x squared e to the x minus 2x e to the x minus 2 e to the x. You could say minus 2c, but again, c is just a constant, so let's just keep calling it a constant, plus c. And oops, the other thing is there's a negative here, so that should become a positive 2e to the x. There you have it. How fun was that? And guess what? Sometimes it works out so you have to do parts 3 times, or 4 times, or 5 times. I'm not going to make you do 5 times, but you might see 3 times somewhere. All right, last one. And for this last one, let's do some bounds. It's the integral from -1 to 3 of x e to the negative x dx. What do you think you want to let u equal? No logs, no inverse trig. There is a polynomial again because x is a polynomial. That means dv is e to the negative x dx. What's du going to be? 1 dx. What would the antiderivative of this be? Well, the derivative would be e to the negative x times -1. So this is going to be e to the negative x divided by -1, or just negative e to the negative x. You could also use u sub to do this. U equals negative x. You know how to do that. But you can kind of do it in your head as well. I'm fine with that. So now we want uv minus the integral of v du. So u is x times v is negative e to the negative x minus the integral of v, which is negative e to the negative x, du, which is just dx. Oops. Sorry. All right, and since I had these bounds originally, this isn't, I know we're using u, but we don't need to get new bounds. It's not really u sub. It's still in terms of x over here. So it's still from -1 to 3. So this is going to be negative x e to the negative x. And incidentally, this piece is also going to have to get evaluated from -1 to 3. You'll see that in a second. Minus, I'm actually going to make that a plus because I could take this negative out front. And then the integral of e to the negative x, again, is going to be e to the negative x divided by -1. All evaluated from -1 to 3. So again, when I say all evaluated, I mean this part out front as well. So it's going to be -3 e to the -3. Let's just make that a minus in the middle there. Minus e to the -3. Subtracted from, plug in -1. A negative -1 would be +1 e to the -1, which again is positive. Minus e to the -1 is e to the first. Okay, so -3 e to the -3 minus 1 e to the -3, that's really -4 e to the -3rd. This is just e to the first minus e to the first. That's going to go away, minus 0. So my answer is -4 over e cubed. So that's what e to the -3rd means. All right, and there you have it. So now you pretty much know the entire AB Calculus curriculum. Homework is problem set 115. Now, two things. You might notice you don't have a problem set 115. Here it is. This unit 8, integration by parts, is a really short unit. There's only 3 problem sets. I'll send this and post it on my website, send it in an email, however you want to get it. You can just take a picture of this page too if you want, but those are your 3 problem sets. You can do problem set 115 right now. You can see some upcoming dates that we'll talk about shortly, or I'll be emailing you about shortly. The other thing, let me pull it up real quick. Here's the textbook answer key, so you can be checking your answers. I will post this on my website as well, or maybe email it to you. You can get it either way. We're skipping section 8.1, but here's 8.2, integration by parts. You're going to see some weird work. They do this tabular method, they call it. Obviously, I'm not teaching it that way, so if I see that, I know you're just copying the answer key and you have no idea what you're doing, but your answers should come out to be the same. So use it for the answers, not necessarily the tabular method. And some of them they do our normal way, where they let U and dv and all that equal 2. All right, so have fun with that. Good luck. I will talk to you soon.